Okay, students. So I will be describing you the basic setup for the light runner experiment. So this is basically like a entire experimental setup which combines many different experiments actually. So here you see that there are many different ports where you connect your external fiber optics or external setups, and in addition to that, you see, if you can zoom in, and you will see that these are a set of 5 lasers that are available to it. There is another laser available to it, this one, which is a pump probe laser. So you can control different aspects of this laser using this knob, as well as there are some other options for controlling that laser. Okay. Other than this, these are diode lasers here. All of them are in IR range. One of them is like near red end of the spectrum, 850 nanometers. The rest of them are in the IR range. Okay. Then there are different amplifiers, connectors. There is something called couplers. So all of them will not be using in our first 2 experiments. Only 2 of them will be using a coupler and a decoupler. So this is a coupler, and this WDM is sort of a decoupler. So we will use that in one of the experiments. Other than that, this here that you see on the right side, these are detectors. As you can see in the name, these are detectors. Okay. So different detectors are suitable for different ranges of IR because they are very simplistic detectors. So except the last one, all the other 4 detectors, they are for IR lasers. That is for these IR lasers. The lower one is 850 nanometer, that is connected to this one. So the constructions are different. So you can look into the manual for details, more details. Beside each of these detectors, you see there is a connector for a BNC cable. So you can connect, take the signal from the detector, that means the output of the detector, to this BNC connector. You can take this out from here, and then you can connect it to a DSO, okay, for display of the signal. This device itself has a built-in DSO, where this is like the channel 1 and channel 2 of the DSO. That means oscilloscope. Okay. So you can turn on an oscilloscope and it will display oscilloscope. Right now, this is the default screen, default open screen. Okay. Now, all of these devices, these are basically your connectors, if you can see. Okay. So these are also optic fiber cables. So this we will be using for connecting to different instruments and setups. Yeah. So as you can see, they are all covered with a dust cover. So you have to basically put this in, prevent it from getting dust. Other than that, I will just show you once how we connect and disconnect these things. So basically, every time, as long as the light is going through this fiber optic, the loss is very minimal, right? But the moment you connect 2 of these, so basically light has to not jump through any air gap, right? So the connections must be very tight, as tight as possible, for the loss to be minimum. So you have these mechanical contractions. So for example, there are grooves and all here, spring-like attachments. So you have to push it, and you will hear a sound like tack. So then you will know that the 2 fiber optics, this end of the fiber optics here and the other end of the fiber optics inside the system are in close proximity. Okay. So you can also remove them by pushing them out. Other than that, we also have this larger fiber optics. So these are like 1 kilometer, 3 kilometers, and 2 kilometer length fiber optic cables. Again, you see there are connectors at the end of these two, the 2 connectors at the end of the cables. Okay. Also, there is an external power meter, which basically plays the same role as the detectors, but this is more sophisticated and gives you much more accurate measurements. So you can take output from one of the lasers and put it in its input, and then you can get an accurate measurement of the power of the laser. So usually these lasers are around 1 milliwatt to 2 milliwatt power. Okay. We also have an external multimeter to display voltages and all. Other than the DSO, we also show you the voltages. Other than that, you can also display it. Okay. So that's about the basic description of the overall instrument. Other than that, you can see in the screen. Excuse me. In the screen, you can see there are different options. So these are meant for basically there is a microprocessor inside which controls the entire experiment. Okay. So you can select different options from here and do different experiments. For example, if I click on experiment here, if you can zoom in and see, you will see there is a list of several different experiments. Right? So each one already has some built-in information inside it. So how to do that experiment, what are the different settings and all. Okay. So for example, if I open attenuation in optical fiber, so then it will show you a different screen, as you can see. Okay. And see, it is also already started displaying oscilloscope. Okay. So there you see different lasers you can select from here, different frequencies of the pulses. So all the output lasers are in the form of pulses. Okay. So this is the frequency. There is a frequency of the light that is related to this wavelength. There is also the frequency of the pulses, so which is this one. Then there is a duty cycle, that means how much time it is, how much time it is off. Also you can control the laser powers, which detector you want. Once you connect one of the laser to one of the detector, it will show you some reading here, which will basically be the power that it detects. Okay. So there are different options that you can control and you can run your experiment. Okay. So this is the basic description of the setup. Next we will show you one of the experiments.